And welcome back to lesson 10.1, inverses of simple quadratic and cubic functions. In Explain 1, we'll be going over finding and graphing the inverse of simple quadratic functions. So in this problem that you see here, we'll see that what it's going to ask us to do is restrict the domain of a quadratic function and find its inverse. Confirm that the inverse relationship using composition and graph the function and its inverse. So first things first, let's go ahead and try step 1, which is to restrict the domain. Just so you know, for this one, for many of these problems, when they ask us to restrict the domain, we're going to only include positive numbers for our x value. Now there's a fancy way we can write this using a mathematical symbols. Essentially, for all values of x, we're going to have all positive numbers. So think of it this way. I'm going to write 0 because 0 is not a positive number, but that's kind of the lowest number we could have. So we're only going to include positive numbers. So think about it. Are positives greater than or less than? So let's think about it, less than or greater than 0. Well, they're usually greater. And we're going to say or equal because we could include 0. So this is going to be kind of our step 1 for the next couple of problems, just so you know. For step 2, what we're going to do is instead of writing f of x, we're going to write y instead. And much like we did in some of the engage activities, we're going to go ahead and solve for x. So I'm going to go ahead and solve for x. What's the opposite of subtracting 6? Adding 6, right? So that'd be x to the second power equals y plus 6. Alright, the way we get rid of, by the way, if anything's squared and you need to get rid of it, the opposite of that is to square root it. So let's say in this case, like this is an example of that, that would be x equals square root of 9 is 3. In this case here, we'll square root both sides, and I'm left with x equals the square root of y plus 6. Step 4 is to switch around the x and y, so instead of that being an x, I'll put a y here, and instead of that being a y, I'll put an x here. Last thing is to replace y with f inverse of x, just to keep that terminology going. Now it is asking us to confirm the inverse relationship, but we can also confirm that relationship by graphing. Graphing both x squared minus 6 and the square root of x plus 6 using our Desmos calculator, which we'll go ahead and do right now. And notice how, since we're restricting it just to the positives, we're only going to really include this quadrant here. And we're just going to see if they are indeed inverses. So let's go ahead and look at that on our Desmos calculator. Alright, so we opened up our Desmos calculator just so you can kind of see where I was able to get that from. So I clicked on Desmos and a bunch of these options popped up. I want the graphing function, so I'm going to press Start Graphing, and I'm going to type in our equations. I'm not going to use f of x, just so you know, because that Desmos calculator only deals with y. So we're going to write y equals, just in case you're wondering, well, how do I put in an x or any of the other stuff? This does have a keyboard, so I can write in x squared minus 6. Okay. For the next equation, I can also write in y equals the one we found, which is our inverse, square root, there's the square root symbol, x plus 6. And what I'm going to do is I'm also going to type in that kind of diagonal line that you saw on our graph that was on our piece of paper, which is y equals x. And I'm kind of just going to zoom in just for the positive part, because remember, that's all we're really concerned about. You can kind of see that they're actually a reflection of each other. In fact, they meet right here in the middle. And these points here are kind of an inverse of each other, whereas this one's 0.2, 0, 2.449. This one's 2.449, 0. So these ones are inverses because they kind of reflect over that line. Okay, so remember how I said we didn't have to always verify with composition. We could just visually see like, oh, they're reflections of each other. But take some time to go ahead and graph this out now that you have a picture onto your piece of paper.